Bismillahirrahmanirrahim. Assalamualaikum, good morning. Tan Sri President of Akademi of Sains, Managing Director Professor Dr. Ahmad Ibrahim, academicians, colleagues, ladies and gentlemen, I want to thank you for still staying in this room after Professor Kamaruzzaman's excellent presentation. I have been with academics for almost 35 years, and there are a few things I have learned. One of the things that when God created the planets, designed and created the planets, all the energy needs has already been there. And lesson learned number one is that the world will not run out of energy till the end of the day. Please bear with me if you have some other opinion, we can argue afterwards. The second lesson that I learned is that the world is actually divided into two in terms of materials. One is energy, the other is non-energy. And we are part of energy actually. Our body is actually part of energy. And lesson number three is that energy has to be green. Has to be green in order to be to meet the design specification when it was originally created. And lesson number four, we have been wasting too much energy on this earth. And finally, last but not least, that global warming, climate change is temporary matters. Eventually, the earth is able to, in fact, the earth has its own mechanism to make the correction. All about climate change, global warming, CO2 is a temporary measure. And we have to create a big and optimistic picture on this earth so that people live happily. Then what is the fuss about green, the fuss about global warming and all this? I think there are two things here. Number one is about energy security. All nations on earth wants to be sure that they have the energy supply. And the second one is the reduction or reducing the waste of energy. And the title that I'm going to go through, and I promise that I won't repeat what Professor Kamaruzzaman has already presented, is that looking for green energy solution to our energy needs. And when we talk about green, I think now in Malaysia, as far as color is concerned, it can be divided into two. One is blue and another is green. So that green that I'm talking here is not that green. Okay? I'm talking about green that is more sustainable, less polluting, clean, and also available for a long time. It's not finite and it's not limited. This one Professor Kamaruzzaman has not presented, so I am going to talk a little bit about this. The thing is, petroleum, coal, all these fossil fuels, we call it, will remain there. Will remain there until the end of the day. And this is the basically what we have today as far as the sources of energy is that very few biomass, very small biomass. Oh yeah, okay. And we have oil here. We have coal. This is oil. This is coal, and this is natural gas. And you have still nuclear and hydro and biomass and others. So is the prediction that by year 2030, the percentage of biomass will increase to about 30%. Yeah. And electricity, as Tan Sri mentioned just now, is that we are talking about thousands megawatts, and the planting is, as he mentioned, is that it's almost, the demand is almost never enough. And the fact is, if Malaysia were to be transformed to an industrialized country, power is definitely indispensable. Without power, we will not move. And over the world, actually, these are how the sources are used. 30%, almost 40% are coal, 70% nuclear. Despite the Fukushima's tragedy and Chernobyl and all this, nuclear is still green in the sense. And you have hydro, oil, and gas for electricity generation. So the trend here is, for as far as electricity generation, coal is the preferred. Coal is the preferred. And what Tan Sri mentioned that, but unfortunately Malaysia has no coal. We don't have coal. We do have in Sabah, in Sarawak. Yes.
Huge amount.
Yes, huge amount. Thank you for correcting. But the Sabah and Sarawak school has slightly lower quality in terms of calorific value. Sabah is
better.
Yeah, and the irony is that coal power plant is not well received in Sabah for some reason, and that's beyond my scope of discussion today. And I think this one I must say that has been already touched by first speaker, that it's by year 2015, 2020, actually demand exceed supply. But we have to take this information with more careful, because who knows 30, 40 years from today. Being a professor, being an academician here, our job is to make prediction. Just like where Bomo actually, traditional Bomo make prediction. They always predict the future. But the future, when by the time the time comes, he is no more there. So we are in the same boat here, that our prediction is that by year 2025 and beyond, the demand is more than supply. Why we predicted this kind of scenario? Simply because we want the energy cost to increase. You know the basic rule that demand and supply determine the cost, and if the supply is less, the demand is more, it's justifiable to have higher energy costs. This is my own opinion, please argue later. Same thing in oil. Before the pre-embargo is very cheap, and now in 2010 we are already about 100. There's a blip here, $130 per barrel, and now we are looming around somewhere 100. Here we are around here. But looking at the trend, I can predict that the cost of oil will not go down. As here in Malaysia, that what comes up will never comes down. That's also based on the long observation and until today. Of course, when the crude oil increase, the price on the pump also increase. Yeah, the price on the petrol pump increases. The good news is that in Malaysia we are still the cheapest as far as our gasoline price, and we have about 50 or 80 cents per liter subsidy. Of course, the quote-unquote subsidy is being taken away bit by bit, and my prediction is pump price will also increase, and that's something that is we have no other choice, right? Also in other parts of the world, in fact, if I never, Thailand is probably 3 times more expensive than here per liter. Now, of course, I don't have to go into detail about if the energy cost increases, what will happen to the rest, the foods here. And also one of the lessons learned in life is that in the world you have only 3 issues. We call it few, not many. Food, energy, and water issues, right? So this energy is part in the middle. So if the oil prices increases, of course, the very strong correlation, and study has been done elsewhere that the food price will increase. And as we know, when the price of per liter has been increased to 20 cents, immediately roti canai, teh tarik. In today's newspaper, you can see that when the sugar price has been increased, it was not responded very well at the mamak stall, and people ordering tea without sugar, so they are charged the same thing, $1 per glass. And I think that's a lot of monitoring to be done. Now, global CO2 emission. As I said, the story on climate change and all this will basically is an explanation for us to be sure that we have to change the way we generate and use energy on this earth. We cannot anymore waste energy. And in coal power plant, for example, the efficiency of energy is probably less than 50% unless it is combined with other technologies, which is actually the green solution that we are talking about. So the CO2 has been, CO2 is not a good word today. CO2 has been labeled as something that can cause a lot of problem, but CO2 actually is needed, and CO2 can be a building block for other material that we need, and that includes methanol and ethanol. Maybe you can, being a chemical engineer, I can also make that as a building block rather than cursing CO2 all the time and without offering any solutions. But CO2, for every tons of coal used in the power generation, you always have almost more than 50% of it is CO2 released to the atmosphere. And the temperature surrounding the power plant is definitely increased, but then eventually it will level off with the rest of the temperature. So the sources of CO2, you can see here that here 44% come from electricity generation power plants, and some from roads, car that we use today emit CO2. CO2, by the way, is going to be used as the standard of cleanliness of our usage of energy. And in Europe, Euro 6, I think Euro 5 standard has already been implemented, where if you emit more than a certain percentage of CO2 at the tailpipe, you will have to pay more. So this is the principle of polluters pay. If you pollute, you pay. So the whole thing, all this thing is about sustainability, it's about business, and it's about not wasting of our resources. The prediction in the future, as I said, oil will remain to be there, gas will remain to be there, it will be found somewhere. It is more expensive, of course, but the prediction, again, we academicians here in Academy of Science must be able to make long prediction based on the fact today, and by year 2030 there will be about 17 or 20% or 30% of renewable. And renewable is being used and accepted as the new players in the market. And if we don't play according to the game, we will have to pay because of the concept of the polluters pay. So we will definitely have to pay more if you actually not changing the way we generate our electricity. And here, the conclusion on this part is that renewable energy will be more significant in the future. So the question is, what are we doing here? We have to get ready for it now and for tomorrow. Here, some of these are renewable energy. Prof. Kamuzaman has touched a lot on this and this. It's hydro, Bakun, he mentioned about Bakun, and wind. Malaysia is not very much of wind. We are not that windy, only in certain islands in the Pulau Layang-Layang maybe. And this is the waste from the biomass from the palm oil palm. Very basically is fuel. And this is what I'm talking about, waste. We actually waste. Here people in Kuala Lumpur actually waste about 0.8 kilogram per day. Throw it away in the garbage, in the rubbish. And what we can do about it? How can we, some effort recycling on this, but still we are talking about the most is about 0.7 kilogram per person per day. So a lot. And as I said, this part is actually the energy part that we actually been wasting all the time and causing a lot of problem. We want to build incinerator in Kepung, nobody wants. We want to build incinerator in the Broga, so nobody wants. Yeah, and that NIMBY concept, not in my backyard. So you can do whatever you want, but not in my backyard. Yeah, this is a typical human being, including me. So you do whatever thing, not waste, not in my backyard. So the question is where? But by looking the positive aspect of municipal waste is that you can convert this into ethanol, and ethanol can be used in the car, and ethanol can also be used and mixed in the power generation, which is actually renewable. The renewable in the sense that unless all of us actually start to reduce our waste, and we can have zero waste. And then the nuclear, I think we are still in the feasibility study on as far as nuclear is concerned. I understand that Tan Sri President also is very expert in nuclear, and of course we have our own opinion about nuclear. But nuclear is the only non-hydrocarbon that is actually green. Yeah. Algae. This is a very, very big potential. The algae, a lot of waste actually, whether it is palm oil meal, effluent, pomade, whether it is animal waste, when they go into the water system, there is bacteria or some other microorganism that can then convert all this organic waste to algae. And few years ago, we have been talking about spirulina. People are very fond about spirulina until when they said that originally was come from the pig farm waste that is converted by algae to green. So here, algae has been one of the big potential in the future, because because you waste, and then the waste will grow algae, and algae can be turned into ethanol using a very simple process of conversion. Bioethanol is actually ethanol that is produced from waste material. In the state, we have a lot of bioethanol that is mixed with the petrol in the palm. But the raw material comes from foods, and there's a lot of debate about that. You cannot use food for energy, because food is more important for people to eat, not to be converted to energy. Now we have the solution that whatever biomass or whatever waste, organic waste that you mentioned previously, you can actually convert that through certain process, fermentation or pyrolysis, whatever, to ethanol. And ethanol is liquid, and it can just be used in our car. In Thailand, they have E20. In some part of the Brazil, they have been using ethanol from sugar. And you still, if you use ethanol in the internal combustion engine like our car today, you still emit CO2, but actually the net CO2 is zero, because the CO2, when you produce the algae, they will use CO2 from the atmosphere. So the net CO2 is actually zero. Now, this is the current, one of the biggest potential of technology. that converts biomass, including municipal solid waste, coal and so on, in the what we call gasification process. You turn that to at certain thermal, at certain temperature. All these hydrocarbon will be broken up to carbon monoxide, partly is carbon dioxide plus hydrogen, and that's called a syngas. And syngas in a single step, chemical engineers knows that it is Fischer-Tropsch process, where actually gas is converted to liquid, and you get ethanol. And this is now in the state, in the some part of the world, they have already built 1,000 tons per day system to produce ethanol for fuel. And here we are still talking about incinerator, but I think eventually we will choose this process because not only it is viable, but also it's actually giving the total solution to our waste management system. And biogas is actually methane plus carbon dioxide. And in the oil palm industry, there are more than 300 palm oil mills that actually generate waste, and they actually store it in the pond. And the pond, from the pond, the bacteria actually is working to convert it to methane. Unfortunately, the methane is released to the atmosphere, and studies show that methane gas is 5 times more potent than CO2 in terms of global warming. And now, fortunately, the simple technology can now be used in oil palm industries, in including even sewage. And the technology is very simple. The waste in the slurry form, you put it in the sort of container, and then you have aeration. And the bacteria actually is helping us to break the molecule and release it to methane, and the biogas can be used directly. If imagine you are remote in one Jangka Pahang in an oil palm plantation, you cannot. It's very expensive to bring the grid supply to that area, and wasting the biogas. So now the technology is available and it's already being used here in Malaysia, producing megawatts level, not just kilowatt but megawatt. And this is what we call the low-hanging fruits. Now it's actually reducing the cost of oil palm meal processing, and it is actually one of the quick win. If the technology is everywhere available, and we can actually make use of it. Now, when we talk about hydrogen, the really green solution in our energy need is actually converting whatever the fuel and the coal to hydrogen. Because hydrogen is energy carrier. The only thing that can happen to hydrogen is you use that in a car, your byproduct is only water, because hydrogen plus oxygen, this is Form 5 science, hydrogen plus oxygen is water, nothing else. And hydrogen can be used for combustion engine as well as fuel cell, which we can talk a little bit more about fuel cell. And the hydrogen path is, I think this one Prof. Karmuzaman has already explained it. I dare not to, because I promised not to repeat what you said. Now, hydrogen system. Any efforts to increase efficiency of our energy generation today can be, we can use hydrogen. Actually, we can hybridize that. We can mix whatever the conventional technology with hydrogen to get the benefit of higher efficiency. And if it is higher efficiency, you have less pollution. Less pollution means you have less cost, and then you can actually reduce the energy cost. So if even, for example, if we have no choice except to pull the subsidy out from the system and we get more per liter, but with higher efficiency, whether the engine, whether the generator, whether the genset, then we actually can offset that increase in energy by having hydrogen as the hybridizer, we call it. So here, our car, you can mix with hydrogen on board generated, and you can actually save more than 50%, 30%. If our car, if we spend about 1,000 a month on petrol today, and we can hybridize that system with hydrogen. Actually, we can now reduce to 50 cents, only 500 ringgit only. So this is one of the options, and the benefits in terms of environment is obvious. Fuel cell, I think we all know fuel cell actually do not use combustion. Fuel cell only use electrochemical reaction using catalyst, hydrogen plus oxygen, you have actually water plus electricity, direct current. And there is no combustion. And because of that, the fuel cell is very simple, the design is so simple, and in the car like this, you only have, in the fuel cell car, you don't have piston, you don't have spark plug, you don't have lubricants, and you have less moving parts. And this technology is so simple. And in life, usually, anything that is very good is actually simple. And if we are so complicated, meaning we are not that good. So be simple to be good. So here you have, very simple, you have only the motor, which is electric motor, and you have air coming in. This one is definitely, but air is not used for combustion, but it's only used for electrochemical reaction. And you have hydrogen storage. Professor Kamal has mentioned that it is safe. It is safe. When we actually have a retreat last time talking about the way forward to have a roadmap for renewable, one of the keywords is demonizing hydrogen, because hydrogen is portrayed as very dangerous. It's like, yeah, very, very dangerous. The first question we say, nanti meletup, you know, explode. So we are not actually, we can. Engineers, like Tan Sri said, we like to solve problem, and we have actually solved that problem of meletup of hydrogen. So you have energy storage, and then we have, so only this. You don't have piston, you don't have nothing, much less mechanical part. Again, this is what we call powertrain, hydrogen storage, and rechargeable. This is some battery here, and then you have the converter, and this is basically your fuel cell stack system, and that's it. And then you can have a car that is zero noise, tak ada bunyi, zero emission, no exhaust, and the only byproduct you can collect and drink. It's better than mineral water. This is pure water. Yeah. And then the bus. Yeah, this is actually per storage in the hydrogen. 4 kilogram is about 4 gallon of hydrogen in the car. Put it in the cylinder, high pressure cylinder, about 350 bar, and you can drive 400 kilometer. Yeah. This is the different option for storage. For example, you use metal hydride and so on. But the best actually to store the hydrogen in the car is using high compression of high cylinder. And technology now is available that the cylinder is very strong, aluminum wrapped up with the carbon fiber, and you can actually drive. Imagine you have a car, you fill up here in KL, 4 kilogram of hydrogen is about 4 gallon. 4 gallon is about what? 40 ringgit, 40 ringgit, and you can drive to Padang Besar, 400, without refueling. Isn't that beautiful? And you don't worry about, if you use electric car, you worry about somewhere in the middle of Kampa or somewhere there, suddenly your battery run out, and you have to charge it for a few hours, maybe half an hour, but not for fuel cell car. And this is what we do in our lab. We actually try to prove that fuel cell, no engine, zero noise, does work. And then we started this project. And some of our students, this is not student, this is me. But people say this is, actually you are against the law because you don't use helmet. But I said, it's just in front of my lab. So it was okay, just to make sure that. So for this project, we want to prove that what is the economic aspect? How many kilometers per gallon of hydrogen equivalent? And we have, the powertrain actually, as I mentioned, this is how we design. We call it triple hybrid powertrain. This is basically the wheel. You have a motor, and then you have the sources of energy, of course storage, ultra capacitor, and then you have fuel cell stack, and then you have hydrogen here. So that's all, simple. The most challenging part in the fuel cell motorcycle is the space, because you have to put the tank, the cylinders, this very limited space. But in a car, it really is not an issue. So this is how we put it on the very limited space on the motorcycle. We put the tank here, and there's some cooling radiator here, and the rest. This is our specification. This motorcycle was actually won 3 awards in South Africa. We brought this motorcycle in South Africa because we are actually participating in the challenge against other green vehicle like solar and other things. So we designed that the maximum speed is 100 km/h. It is so that this motorcycle can go on our highways, but bicycle cannot go on the highways. So we have to have 100 km. What we achieved after the test in South Africa, 4,000 kilometers, 1 month race, and I was not there. I went there only one week. The rest are the student. This is a German student, graduated already, now working with NUS in Singapore. And this is what we achieved is 100 km/h. Maximum distance without refueling. So the hydrogen in the 2 cylinders at the back here is equivalent to 1 gallon, which is 1 kilogram. So we designed that without refueling is 410 km. What we achieve is 150 km. The reason is simple, because during the design, during the fabrication of the motorcycle, the student keep on adding weight. Yeah, it's not according to the design. So they said, tambah itu minus this plus 1. So in the end, actually, it was not according to design. That's why the mileage is less. Fuel consumption, we once need to be 500 km per gallon. We achieve 300 km per gallon. And the rest. And energy saving, we have regenerative braking. If we brake the motorcycle, it is converted, instead of heat wasted, we convert that to energy to charge the battery. So exhaust, pure water, we achieved that, pure water. Emission 0, yes. And noise, well, actually during the things not measured, we expect to be normal noise, which is 75 decibel. This is a short video clip. The noise is stealing from my car when I took the picture. So this one is no noise. Hyrule is the one that is driver. We choose the not very heavy drivers that we win. I think this is somewhere in Durban in South Africa. You can see no fume, exhaust, anything. And South African highway is quite rugged and mountainous, and the weather was really certain part raining, certain part in October is between cool and summer. So we proved that the system actually works, and it's simple. I mean, we can do it ourselves. Of course, some of the components have to be purchased. And the green solution is also now being widely researched, and even for this one, Boeing now has aeroplane that actually run on fuel cell, on fuel cell. So in the future, if you are on the plane with the fuel cell, please be careful, wear your what you call the parachute, just in case something wrong. Here is one of the designs similar. The powertrain is similar, that instead of wheel, you turn it the kipas. Even the hydrogen ship now is already being built, and I don't think they are going to commit millions, hundreds of millions just for demonstration, and this is real commercial. Smart grid, I'm not that expert in smart grid things, but apparently now in our grid supply there's a lot of losses from the power plant to the room, there's a lot of losses, the energy losses because of this grid connection. And not only energy is lost at the source, at the power plant, but also when it arrives here, there's so much loss. Probably in 100-ton coal, probably less than 40 tons actually is the real thing. The rest are actually wasted in terms of feed as well as other things. So we can actually, the first thing that we can do today is to save some of these energy losses by actually converting off-peak power. I was told that in Malaysia today, if we have 20,000 megawatt a day, maybe Tan Sri can help me. So the real power that is used is only about 12, on the normal average about 10,000 or 12,000 megawatt. But 3,000, 15,000 megawatt is actually the safety, the rest is reserve. But there's always 3,000 or 4,000 megawatt a day that is not used, wasted. Maybe Tan Sri can help me there. But if we can take that amount of megawatt, 1,000 of megawatt, and convert that to hydrogen, and the hydrogen is then used to power fuel cell or other things, and then put it back in the grid, probably the load shedding, the peak load shedding will eventually be reduced. And that way we can increase the efficiency as well as the cost. And we can expect that the tariff, our tariff now is 28 maybe cent per kilowatt hour. So in the future you expect to be more. Yeah, by having this, then we can actually either maintain or reduce our tariff that we pay. I think some of the smart grid is complicated. I think for us to understand in this room, only the academician who has the wise wisdom to probably read. But I think the whole idea is about how to make sure that our grid system is stable, less disruption and so on. By the way, our supply in Malaysia is one of the best in the world, with not much actually outages. Sometimes here and there, but we is one of the best, and we have to commend that in Malaysia. And I have a Nigerian student who, when he came here, he was so amazed about two things. Number one is the power supply, that we always have a constant power supply, 365 a day in a year, and also water supply. And he said that in Nigeria, that is like a dream, to have electric supply. And in fact, one of them actually wants us to install fuel cell there. The reason is that because of this so bad supply of power, they start using genset. The HEF class actually want to buy genset, and a lot of people actually die because they put their genset in front of the apartment, and the CO poisoning start coming in. There's a lot of people die. So they want fuel cell because they said fuel cell. The only thing is the infrastructure that is yet to be established, and there's not many fuel cells providers actually operating in Nigeria. An opportunity for us to probably look into. Now, I have mentioned the fact that we have to reduce energy costs, and green solution can actually assist or help that objective. And by increasing the efficiency of our generation, reducing the losses, and also the probably design the grid system. For example, we have more IPP, independent power generation. It is a small, we're talking about 1-2 megawatt, but if 1-2 megawatt per IPP using fuel cell hydrogen, for example, if you have 1,000, it's already 2,000 megawatt. So at the end, actually we are strengthening the grid supply. We are reducing the losses through the grid, and eventually we can have better quality and secured supply. Hybrid vehicle with hydrogen, actually you can use hydrogen now in our car to improve our car efficiency, and we can actually generate hydrogen on board, on board of course, car, and of course fuel cell engine. There are a lot of ideas that is already being tested today in Malaysia, and the Prime Minister has already committed to the world that they want to reduce carbon dioxide emission over a certain number of years. Though I think we should look more detail about whether the target is achievable and how to achieve that. And this is green solution. There should be some demonstration project need to be carried out in order for us to meet that target. So fuel cell engine, electric vehicle right now is being talked about, and Putrajaya is trying to install electric vehicle. But again, if the application of the electric vehicle is beyond urban areas, then people might not accept that, because of the fact that you are driving at night somewhere in Pahang, suddenly you are run out of battery, then you have problem. Now, the whole thing about a green solution is about actually creating new businesses. Power plant and also car has been there. The technology has been there for ages, and there was almost no improvement. And as I said, energy is going to be here in this planet, but the question is about the business part. We want to create new activities. We want to have new businesses, and the model of that has to be really acceptable, and by the people, by all the stakeholders. And we already have policy on green energy, Sustainable Energy Development Authority in Kedah. We already have that, and fit-in tariff is one of those experiments. Of course, it is a little bit skewed to the solar. Prof. Kamuzaman is happy because you install solar, you're getting 1 ringgit 26 cents per kilowatt hour, and so it's big. But if you're producing the energy from hydrogen, from other things, probably it's about 30 cents, 40 cents. It's not attractive. But the real market is really, as I mentioned, is the where it is not actually connected to the grid. You can have isolated power on the island, all this. So this is actually but it's not that attractive. But at least now we have a policy on sustainable energy, that fixed-in tariff. As I said, European now has already implemented the standard where they are going to measure the CO2 at your tailpipe. Certain part per million of CO2 you have to pay. And imagine that if you are not ready by 5 years from today, that we have to pay all the unnecessary costs because of we are not meeting the standard of environmental pollution. And we all have to accept that environment is beyond borders. We don't have any border. This is our environment, this is your environment. In fact, what happened in haze every year is one good example that we have to learn. And if the chicken and egg situation, people do not produce fuel cell or hydrogen-based system, is because of there is no demand, and the demand is not there because of there is no supply. So the vicious circle has to be broken, and I think the government has the ability to break that vicious circle, the chicken and egg situation. So if the green solution is produced in mass, in volume, then now you can actually offer to the customer less cost. So and therefore I think the government has that ability to change the situation. And as polluters pay, it's already been accepted worldwide that if you are polluting, you have to pay. The question is, can we pay or not? If you cannot pay, they will shut down, and we have no power. And of course, green solution can now contribute at a small scale. But as I said, 2 megawatt per station, you have 1,000, you have already 2,000 megawatt. I've talked about this efficiency. Some of the examples, on the electric vehicle. So for electric vehicle, you do not want to use hydrogen because you have to use battery to get, because it's higher efficiency. But if you want to use hydrogen for fuel cell, the hydrogen sources had to come from somewhere. It's already on sale. Those of you who wants to buy green vehicle, so Nissan is selling at $32,000 US. Of course, this does not include our tariff. If you come to Malaysia, probably you got to pay 2.5 more, times 2.5 more of this. So this is US dollars. So it's not much actually. Nissan and Honda is selling at $21,600. And this is Mercedes. Of course, Mercedes is more because you pay for the brand, for the Bintang 3. So, efficiency for coal power plant is only about, if it is coal, it's only less than 35 if nothing is done. So I think we have to change that efficiency of the coal power plant. And for if we use natural gas, it's a bit higher. This is a bit out of date data. And this is average efficiency for coal power plant. Malaysia is not here. They're talking about they do improvement on the efficiency, but Denmark actually has the highest 41% efficient. Lowest is Slovak Republic, which is about only less than 25%. As I said, maybe Malaysia has some figures, but I'm not. It's not available to me. Hydrogen. If we are talking about the hydrogen world here, all can be converted to hydrogen, and it can be stored, can be used. So electrolyzer apparently is one of the enablers. So an electrolyzer is so simple to do. As I said, anything good is simple. So we can actually build electrolyzers if you want. We're talking about big production of hydrogen, and research has got to be started in that area. This is an example of how the good carbon management, they call it, basically improving the efficiency using certain initiative in the UK, and you can get, in this particular case, 13 million pounds to almost 10. So it's about 30% benefits. So it's there, it's viable, and with some strategies. Fuel cell vehicle, the fuel cell cost is actually 30 ringgit per kilowatt, but I've yet to see this in the market. That's because of that chicken and egg situation, vicious circle. We are not having a big mass production because there is no demand. There is no demand because it's expensive. So that circle continues. So in the CAP, combined heat and power system, actually you can have more 60% as compared to 30% in power plant. So there's a lot of money, from 30 to 60% double. And emission, CO2 tons per megawatt. For whatever megawatt we're producing, that is because of this improvement. I'm sure here in power plant in Malaysia also has advanced further. If you have subcritical process, ultra supercritical, actually you can reduce the emission. In summary, I have to sell and I have to believe in hydrogen. As I said, the world is only divided into two: hydrogen and non-hydrogen and others. So I think we're talking about green solution. Any system that actually use hydrogen is green. And assuming that all the energy sources, petroleum, everything is gone, you have 98% of the world is water. So you can actually use water to split it into hydrogen. That's why when I say in the first statement that when the planet was designed, the energy is already there, and it's up to us how to use it. So these are the 5 reason why we should look for green solution. As a summary, we want to have a better environment, especially in the city. When the haze actually attacked Kuala Lumpur, I was suffocated that sometimes you can actually fall sick and then things like that. So imagine we live in the city that is dirty, and we have to create new businesses. We have to have a economy, and our economy can actually be adversely affected if you don't actually tackle the energy issue. We want to lower the energy costs. On the outset of that, the subsidy will eventually be increased, but I think we can reverse or at least maintain that if we manage our energy costs correctly. And number 4 is actually the most important. All countries in the world today, the energy security, that's why the energy mix in America, in Japan has already been shifted to have 4 sources almost equal 25% each. The nuclear, the oil and the coal, and also the renewable. So they are having this actually the balanced energy mix. In Malaysia today, coal is overtaking natural gas, I think more than 60% coal, and it's getting more and more. So we are over dependent on coal as our energy. So that definitely, if we have to have the energy security in mind in doing this. But I'm sure the planners, the energy ministry has sort of strategies to make sure that we always have security in supply. Assuming that if there is no coal today, at one time China has already banned coal export, so that need to be the of course, as I said, new businesses. We want new businesses. We produce more than we have 23 public universities today, and we have also 200 something private universities, and every year we produce a lot of engineers, scientists, managers, and they have to work. And I think the government's public service cannot absorb more, especially now people like me who's all still being employed, so less opportunity for young engineers. I'm sure that we need to create these new businesses to provide job to our graduate, and energy is part of the lucrative area that we have to look to. I'm very scared to show this slide because the Green Energy Fund has, I think, got to be in place somehow. I don't know where the fund is going to come from. Maybe Energy Commission can allocate a long-term fund, to make sure that we have the ability to carry out research, and our school children also need to be educated about energy. In UTM, we have actually embarked on energy saving plan for the whole campus, and out of 20 million a year on electricity and water, we managed to reduce to 70 million. 3 million is a lot of money, and in UTM. And what we actually did is very simple: educate the staff and the student that if you don't use it, switch it off. That's all. Aircon and also the lighting, and we save about 3 million a year. That's 30% almost per year. So education, I think we have to also think about it at school level. I think we can start introducing this at school level about the way we actually use and manage energy. And hydrogen demonstration, we used to have a roadmap, and I'm sure now we still have that roadmap, and we can have a demonstration project to ensure that we have something to see. To at least we can say that hydrogen is not our enemy, hydrogen is our friends. Yeah? I just been informed today that Akademi Sains has already a group on energy, so I think we could enhance further on the sustainable energy group here. Professor Kamal Zaman, I think is the right person. He has done so many things, and we can ask him to do more things on sustainable energy. establish green energy standard. This is also already been, I think, where SIRIM and some other thing. I think standard also need to be included in building when they have green energy building standard. But I think we have yet to form that, because it costs to the customer. So we say that is index 4, maybe so much, that kind of thing. I think it should be beyond just water focus. Energy should also be included in the green energy standard. And of course, I mentioned that capacity building, that every one of us are actually part of the problem and as well as part of the solution. So unless we change that, the way we think and change our mindset, then we can convert everybody to be part of the solution. I think, thank you very much for your attention.